Hello all my JavaScript friends, this is the Virtuoid, aka Mike Smith, and this is Fun with JavaScript, our racing game. This is video number 2 in our 3-video series of building the track. This particular video is going to deal with the actual track design yourself that you're seeing on your screen here. Our first one dealt with Bezier curves, and our third one is going to deal with building the starting gate and the finish gate that you also see on the screen here, which means we're not going to be covering the starting gate and the finishing gate. So sorry about that. That's going to be video number 3. If you wish to follow along, again, you can always go to the public repository for this particular project. That's under FWJS-race in the Virtuoid account. Make sure you go to branch release /0.0.3. And you can find all the code that we've been using for all the videos in this particular proof of concept for our racing game. So, are you ready to build a track? Let's get started. This is where we left off in our last video, which was the last video of the car series. And so what we're going to want to do, first of all, is we're going to create our HTML and JavaScript files to get our little test page. If you recall correctly, we created an HTML file called testcar.html, which allowed us to be able to have a page particularly devoted for just looking at the models themselves. And we're going to do the same thing here with the track. And so the first thing we're going to do here is we're going to create a new HTML file. And we'll call that one TestTrack.html. And then what I am going to do is I'm just basically going to cut, copy, and paste everything that we have in our other file. Other file meaning the other repository, the FWJS race repository. So now I've copied the code that we're going to use for HTML files. No big deal here. We're using the race PSCS just like we had before. Same icon, no big deal there. Here's our render canvas, our track error. And now we also have a testtrack.javascript file within the JavaScript directory. So let's create that file, new JavaScript file. And that one's going to be called testtrack.javascript. And let's copy some code in there. Okay, and now we got our JavaScript files inside there. Notice that it's saying it can't locate particular directories. Now, basically, these directories are the directories that contain all the math that we're going to be using to create the tracks. Now, again, I'm not going to go through all the math. You're more than welcome to open up these JavaScript files and take a look at them. So let me just go ahead and copy those over real quick. I've got that under a race utilities. So let's go ahead and create the race directory. New directory called race. And let's just copy the utilities directory straight into there. So here are all the utilities that are used to be able to create the tracks that you see there. A lot there. Don't worry too much about it. Again, we're not going to go through the actual JavaScript files on there. TestTrack Live is going to be the track that we're going to be creating here. I am actually what I'm going to do is I'm going to comment that out for a brief second, and then come down here and come out and comment out that. And I believe at that point that will get us working correctly with our browser. So let's take a quick look at that. And when we do, he says this local page cannot be found at localhost testtrack.html. So what did we do wrong? And what I did wrong is I created it inside the wrong directory. Let's move it up to source. Let's refactor. Let's try that again. There we go. Okay, and we're pretty much done because there's absolutely nothing appearing on the screen. It's very hard to see, but there is a little type error that is occurring here, and that's because we have no track defined. So now that we've got the preliminaries done, we've got all of the directories created that we need, we've got all of the Bezier curve JavaScript files all necessary. Let's go ahead and create the file to build the track. Okay, all the support files are in place. Let's get to actually creating the track code. It's called TestTrack Live, and it's imported from a file called TestTrack Live. So guess what we're going to create? We're going to create a file called, you guessed it, TestTrack Live. TestTrack Live. So there's our JavaScript file. And let's uncomment this Test-Track Live right there. So basically what we're going to do here is we're going to call a function called TestTrack Live will be a function that we'll call, in which will pass a track display and a scene. So let's go into TestTrack Live and let's get the bare minimum of code for our demo. Okay, and here's our TestTrack live function that we're going to be exporting. It takes a listing of all the different tracks and the scene. And this is basically how we're going to, this is basically what we need to do is we need to register our track with the tracks variable. And to do that, we pass it a family name. And this family name basically allows this particular track to be part of a family that allows us to be able to later on select different families of tracks or different tracks. So we can define more than one track if necessary. And that's going to be important later on, a long time ago, excuse me. That's going to be important later on down the road when we want to be able to run our races and say, I want to race on this track or this track or this track or this track or whatever, it doesn't matter. By having that family there, we can get a listing of all the different tracks that are available. Also, it's very good for our proof of concept when we're testing out different track layouts. And we get the proof of concept within our repository. And that I'll probably show you when we put everything together in the next group of videos. But the big thing here is that we always got to pass it an init function within the TestTrack live function. And within that, we're going to need to define a track property. And so this is that track property. Here are our segments. Remember, a segment is basically a group of sections, and a section is a set of 2 points. And basically, we don't have a section per se here, but what we will end up having is a series of points. Excuse me, or an array of points. And each of these points will define the different sections that are going to be associated with the segment. You notice this is an array, so we could have more than one segment, and that's very important too. You could basically, if you wanted to build a ramp or something, do a little jump or something like that, you can do that by having multiple segments. We're only going to have one segment here, so there's nothing really to worry about. We'll pass options to it, and this is track-wide options. Normally things like a width of the track or the height or the wall height of the track. There's a number of different functions, and that's listed in the documentation from the doc page that I showed you in the last video. So I'm not going to cover all of that. So as you can see here, we're missing a couple of variables. Let's throw those variables in. And here we go. There's my track width, my wall height, and my family. And so that will pretty much solve all of this. So will it actually run from this point? Note range error. Track segments points must have at least, and of course it's kind of cut off there. Basically what it means is I don't have any points. Because remember, we're going to have at least 2 points to define a track, the entry point and the exit point. So let's do that. And here is my very first point. So let me explain what's going on here. Now, if you go back to our video that we had, we were explaining about the Bezier curves. That's how you actually pronounce it. I was informed by the person who wrote the track program that I've been pronouncing it wrong all this time, that it's actually pronounced Bezier, not Bezier, but Bezier. So when we did the discussion on the Bezier curves, one of the things I told you is that, hey, we had to have a point that the Bezier curve started. We had to have a point that the Bezier curve ended. And with our track definitions, we also had a vector that basically said, okay, from this particular point, how's the track going to continue going? And that's called the forward vector. So the bare minimum I'm going to be able to define for a point is basically a center and a forward. And this center is the vector that the point in the coordinate in our space that will represent the very beginning of the track. In this case, it will also represent the entry point of the first section. In this case, it's going to be x20, y15, and z0. X, if you can think of it on the Earth, X is basically your east-west, Z is basically your north-south, and Y is your up and down. So if 0, 0, 0 was a spot on the ground, basically Y will go underground, negative Y will go underground, negative X will go west, negative Z will go south, Z will go north, positive Z will go north, positive X will go east, and positive Y will go up into the ground. And so what we also done here is that we've gotten some vectors, predefined vectors here that basically give us right, left, up, down, forward, backward, and 0. And these are predefined vectors that we're going to be using with our forward vector. So what is the forward vector? The forward vector basically says which way will the track be going once we start to draw the track. And that's either again going to be left, right, forward, backward, or up and down. And we've gotten these things set up here for positive, negative, X, Y, make it easier for me basically to figure out, hey, what's up, what's left, what's right, because once you get your orientation wrong, left, right could be different things. It doesn't really matter. But we've got the vectors defined here. This is the absolute start of the track. This is the center point of the track. So our track width is 4. That means I can guarantee that 2 parts of the track is going to be on one side of this point and 2 parts of the track is going to be on the other side of this point. So it represents the center point of the track. Forward here basically says that this is the direction I want this particular track to go once it starts going forward. And in this case, I want to go the negative X direction. Or again, if we're on a plane, this will be off to the left or west, basically. So that's our first point. So now we come down here into the TestTrack Live points and we type in track start. Because the points here is just going to be an array of different points. Now, a section always needs at least 2 points. You got to have 2 points. We know where we're starting, but we got to go somewhere. So we need to have a second point. Let's go ahead and throw that in there. And here is our second point. And so basically, again, I'm defining a center and I'm going to be passing it a new vector 3. But what I've done here is I've got myself a little helper routine is that, at least for me, it was easier to, instead of sitting there thinking, okay, I'm going to have it end at this X, this Y, this Z coordinate. It was easier for me to sit there and think, okay, I want this thing to go 20 spaces this way or 10 spaces up or 12 spaces down or whatever. Basically, a change from the current position. So I wrote myself a simple little routine called next, which basically takes a starting center position and a change, an XYZ change, and that will return me a new vector 3 of what these changes will be for the X, the Y, and the Z axis. And so this, in this particular case here, I'm going to say I'm starting at 20. I want to change it by moving 40 negative, which means I want to move 40 spaces to the left, or 40 spaces west. I want to move 20 spaces down from our current position, which happens to be 15, and I want to move 0 spaces Z. So this basically, if you remember a Bezier discussion on the last video, this is going to basically create a straight line. Again, my track is moving forward. My track is automatically saying, again, my track is moving forward, and that basically means I need, and since forward for me right now conceptually is moving west, I need to put a negative X in there. So I want to tell the system that we'll want to continue moving forward. All right, we've got that in there. We've put track start. Let's add in the point. And one more thing I want to add in here. That's actually it. It will work at this particular point in time, but one thing I do want to add is I've got some very special code right here. This code will automatically put a small red dot anywhere on the screen I want to, and then point the camera to that dot. And I discovered when I was working with this particular track here, the longer the track got, the more I had to use the mouse and everything to try to change the camera angle to try to point to where I was looking at. And I got tired of doing that. So I added this piece in here to put that little red dot and to point to 0. And to do that, I had to create a new variable called last on the track. And that last variable is going to be an XYZ coordinate that will allow me to take a look at the or to point the camera toward that particular piece. This is not part of the track itself. Let me go ahead and bring that in. And there it is. So basically, this is, again, like I said, this is not part of the initial track definition. This is just something I threw in there, again, to help myself figure out, I want my camera pointing to the last thing that I did so that, hey, I automatically, don't have to sit there and move the camera too very much to be able to see what kind of mistakes I've made. So now technically it should work. We have our first point, we have our second point. So we've satisfied a section. A section needs 2 points, entry point and exit point. We've got our entry and exit point. We've got at least 1 point in the, or one section in the segment. It should work. Let's save it. Let's go. And bingo, bango, there it is. Let me zoom out a little bit there. So this is what I mean by the red dot. It was automatically pointing toward the red dot, so it kind of helps focus my attention to one of the last things that I did. But there we are. This is all there is to it. Let me get it on angle there. So this is the Y. You can see that it dipped down because I changed the Y. You can see that it ran a good distance here because I changed the X. But notice it's completely straight because I did not change the Z. If I had changed the Z, it would try to attempt to make a curve as it made with the Bezier curves from the previous video. So that's our very first section. So let's add now another section to it. Okay, so our second point is going to be a curve that will go off 45 degrees. And we want to connect it up to the first section. So what are we going to do? Well, let's go ahead and throw something in there and show you what can be done. Let's throw that next point in, or the third point, basically. Okay, and there is our next segment, or our next point, excuse me. This next point, again, has a center that is it's going to come off of the first slope, but that's going to start at first slope, but the end is going to be a change of this circle 45 radius. No change in the y's, which means it's going to be on a level plane. And we've also changed the z off to the negative side. So our curve radius x continues on the negative side, but z is now on the negative side. So this is going to create the effect of a curve in 45 degrees starting from the negative x side, as it's moving negative x, and it's going to end up now moving toward the negative z side. So because of that, on this particular point, I want the forward vector to automatically say negative z, because I want this, if you can imagine the curve on the screen, I want to be able to have that the first point is going to be set for negative x, but the second point is going to be set for negative z, because once it finishes up the 45-degree angle, I'm pointing off now toward the south, or down, or not down, but forward or backward, or whatever the heck it's called, basically south. And so that basically now means that anything that comes from this point onward will always now go into the negative z direction. So we've got the curve 45 inside there. We've changed both x and z, so we should expect it to curve. So let's put it down in our slope here, excuse me, our points, and let's type in curve, if I can spell correctly, curve 45. That should do it. Let's Control S it. Let's take a look at it. And there we go. Our curve is done. That really sucks, don't it? Of course it does, because the problem we have here is that we're missing a few things. If you remember on the Bezier discussion for the last video, there were two pieces of additional information we're going to need to change. And that's called the forward weight and the backward weight. And the forward weight is going to basically start right here and move that Bezier point downward here to kind of help stretch out that curve coming down. Same thing with the backward weight on this side. If we change the backward weight to go this way, it's going to pull out the curve. And so the combination of this pulling out and that pulling out should give us automatically some sort of curve there. Right now it's just doing a straight line from this point to this point right here. And you can tell everything's kind of messed up here because of my negatives, everything starting with the negative x here. It's having to do a quick little curve, and then if it comes back here, it's got the negative z, which is hard to tell here, but there it is right there. It's pointing that away. You know, you can't see my fingers, but it's that away. Anyway, so let's now take a look at the backward weight and the forward weight. Let's take a look at the forward weight first. The forward weight is going to be this point. We're going to need to change this point here. Where was this point defined? This point was defined earlier under the first slope, because this is basically, let me back out here. This is our first point up here. This was the test. This was the track start. This was the second point, the first slope. This was the third point here, the curve 45. So we're going to need to change the forward weight of this point right here, or that's coming off of this point, so the first slope. So let's change the forward weight of the first slope. Let's get that in there. And there we go. Notice I've got a variable here called curve 45 weight. Now let me throw that in there, and I'll tell you why I did that here in just a second. Okay. All right, that gives me a variable I need to change in there called circle weight. So let me add that in there, and I'll tell you why in just a second. And we'll put circle weight up here. Okay, so the idea here is that I've got a certain weight that I want to be able to use on this particular curve based upon this curve radius. The curve radius, by the way, and I forgot to mention this, is I've computed curve radius to be track width times 4. It could be track width times 2, which would be a very tight curve, track width times 8, track width times whatever, it doesn't really matter. You can make it track width if you wish, and that would make an extremely tight curve. I think almost like a 45-degree angle. I mean, excuse me, a 90-degree corner. I really suggest don't do that. But anyway, so the idea here also with this circle weight is that normally what you would do is the weight, both the forward and the backward weight, which we'll get to in just the backward weight we'll get to in a second here, will normally be the actual radius. But this person here on the Bezier, some research on the Bezier circle found out that this number actually works a little bit better. Not exactly half, which would be 0.5, but 0.55191502449 blah 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 blah. That works a little bit better. So what I'm doing here is I'm computing a weight and giving it the circle radius times the weight itself. And so that is what's getting on the forward weight. So again, the forward weight will be applied to the first point in the Bezier curve. And the first point happens to be the first slope, because this is section number 1, this is section number 2. And the thing you can obviously see here now is that the exit point of a section will always be the entry point of the next section. So first slope is going to be the exit point of our first section, but the entry point of the second one. So since it's the entry point of the second one, we're going to put the forward weight on there on the first slope. So let's save that. And let's take a look. There it is. All right, looking better, looking better, looking better. So notice it's looking just a little bit better there. We've got something else kind of going on there, but I'll show you how to fix that in just a second. But you can tell this curve right here, let me bring it up inside the thing here. This curve right here still looks like junk. It's still having some problems with it. And the reason why is that we've only applied the forward weight, but we haven't applied the backward weight to the second point. So let's go ahead and apply the backward weight to the second point. And that is right there. So now I've applied the backward weight to the second point. So first point is first slope. We've applied the forward weight to that. The second point is curve 45, so we've applied the backward weight to that. That should do it for us, right? And it does. That is a nice, pretty little curve. Looks wonderful. Now, take a look at that. This is one of the things you're going to run into. I've got this nice slope here with this particular segment. And then it suddenly, very jarringly, goes into this particular curve right here. And the reason why is I've got this slope here, but this one I've got a y is equal to 0, which means it's on a level plane. Now if I'm going to run cars in this way, as soon as they hit this little corner right here, they're going to just jump all over the place. They're going to wreck basically. So how can we smooth that out? Well, with Bezier curves on straights, the forward weight, let me move this over here so I can show you a little bit better. The forward weight will take the point at the very top there and move it out toward, in relationship to what you're seeing on the screen here, we'll move it out toward the left. Just like this corner here, this 45-degree curve, excuse me, the forward weight moved everything out down. Consequently, the backward weight, which will be applied to this particular point here, will move things out this way, off to the right, just like the backward weight moved it out to the left over here. So the idea here now is if I do the backward weight, that should basically kind of gives us a little bit of a slope going down into here, and maybe it won't be so rough of a jarring angle because of the backward weight giving us a better slope down here at the bottom. Let's just see how that works. Let's go to the first slope here, because the first slope happens to be the exit point of the first section. The first section again being the track start and track and first slope. And so since that's the exit one, that's what we want to change. We change the backward weight of the exit one. Exit one is first slope, so we come up here and we type in backward weight, and let's give it a value of 10. Why that value? I don't know. I just did it just because for fun, whatever. So that now basically means that, okay, the backward weight, that means I'm now affecting the first section. So I'm going to try to bring back the road just a little bit on that big long slope and see if we can't even out that transition between the first section and the second section. So here we go, and Check that out. Look at that. Isn't that pretty? Now to show you kind of how it all works like that, you know, how the backward weight works, burn that into your mind or how that looks. Let's change this to like 40. I mean, let's just really go bonkers with it. It moved it out so much. It's a beautiful sloping curve, but it moved it out so much it really started messing up the track up here. So that's the idea here, is you kind of just want to play around with the numbers until it just, you know, visually looks okay. And of course, once you run the cars on it, they still kind of bounce around. You may want to change that backward weight. So let's take the backward weight back to 10. That's what I used in my demo, and it seemed to work pretty good. So there we go. There's the backward weight. It's got a nice, smooth little transition now to the second section. So that should be okay. Once you start racing cars on this thing, it might behoove you to try to, you know, change the backward weight just a little bit more to kind of get it nice and pretty with that. So that completes section number 2. So the next thing we're going to do is we're going to run a nice long slope off of this section right here. First, what I'm going to do, however, is I'm going to go into last, and I'm going to say that I want my little red dot in camera to be at curve 45.center. And by doing that, now it's going to automatically point to center. So that's going to help me when I start getting this next slope. So let's get in the next section. Now things are going to run a little bit faster here. Now that you're seeing how everything's working, things are going to run a little bit faster. Okay, the next section is called curve 45 landing. And so basically I'm running a very small little straightaway here before I get to the major slope. And this will become very apparent at the very end of the video here when we make one minor change to these curves. We're going to put banks on the curves here. And it works a whole heck of a lot better if we give them some sort of small little landing space. For right now, it just kind of looks weird because everything's still on the level because we're still at 0. This is going to be just a small little stretch. Again, we're starting at, we started at negative Z there. We're still going negative Z because we're still going down that Z ramp. So we put in curve 45 landing. Once we have curve 45 landing there, let's go ahead and take a look. And yep, you can tell there's our 10. There's our 10 there. And again, this will become apparent why I did this. It will become very, very apparent once we do banking on the curves, which we'll show you. I'll show you at the very end here. So now that we've got that done, let's go ahead and do that very long slope. So that's section 1 is done. Section 2 is done. Section 3 is done. Let's do section 4, which is a much longer slope. Okay, I got the big second slope inside here. I called it second slope, which basically I'm taking it from curve 45 landing and sloping it down another 30 and getting the Z way on out there. So this is basically, again, going to be a straight. Since X has not changed, this will be a straight. And we're still along the Z axis here, so we want our forward vector still to be Z axis. So let's go ahead and pop that into here. That will be second slope. And what I also want to do here on the last part, I want to go ahead and move my little, that's curve 45 landing. I want to move my red dot to the curve 45 landing. So let's save that. And let's take a look at it. And there we are. So we're now sitting there on the landing. Notice that we still have the angle there. So let's try to get rid of that angle. A couple of things we might be able to try here. This is a straight right here. What we could do is try to push the forward weight out a little bit. And that forward weight on this particular straight is basically going to basically what it's going to do is going to push about this section right here. I've got it where I'm circling with my mouse. It's going to push this section forward, which will kind of slope this section just a little bit, and that should give us a little bit of a better slope. So that will probably be the easiest thing to do. Let's go ahead and go to the curve 45 landing, since that's what's there. So let's go to forward weight, and let's try about 10 and see what happens. So did that, we save it. Oh, that looks pretty good. Looks pretty good. I still think it's a little bit on the sharp side. What happens if we change that to 20? And again, these numbers are just have to kind of guess at them. I like that one. Now that one actually came out really nice. Okay, that's cool. That's cool. That's pushed out that landing, and now it looks really, really nice. So there's that. There's our. Actually, that looks kind of wicked funky there. Let's bring that back to 15. Okay, that one actually works a little bit better. We've got the slope right there. It ends up to be about right there. And now we got the regular slope going further down further down the pike. Ah, anyway, cool. All right, so that gets that particular point. Let's add another one. So at this point, I'm sorry, what I meant to say here is that the next point here is we're going to add a 180-degree curve down there at the bottom. That's basically going to take us from a negative z to a positive z. And for a curve there, it's actually going to be in two sections, because if you notice here, this Bezier curve gave us a 45-degree angle. So we're going to have to put two 45-degree angles. The first one is going to angle it so it goes from a negative z to a positive x, and then from a positive x to a positive z forward vector. So we'll pop two of them on there. So let's pop those in there one at a time. Let's get them in. Okay, I've got it in there, and just like I did with curve 45, I've declared myself a curve 180 radius, which I have defined up here as track width times 4, the exact same radius that we had with the curve 45, and now I'm calling it curve 180 radius, so I can differentiate in case I wanted a smaller radius or a larger radius that was different. And we're now going positive x, because remember we got two 45-degree angles. So our first one, as we're turning to the left, as I call it turning to the left, as from the perspective of the driver, I'm turning to the left. I'm going from a negative z vector to a positive x vector. So that should give us the positive x vector itself. Now we already know that we're going to have a couple of backward weights inside there. So let's throw those two in there. A couple backward weights, excuse me. A backward weight and a forward weight, just like we did with the curve 45. Okay, next let's get in the backward and forward weights. Okay, so the section is going, the first point of the entry point for the curve will be the second slope. So this is going to get the forward weight. So let's pop a forward weight on there for the second slope. And that's going to be the curve 180 weight. And the backward weight for the backward weight for the curve is going to be on the exit point, which will be curve 181. So let's pop the backward weight on there. That should give us the curve. I'm going to pop this on curve 180-1, and let's add it to our points. Curve 180-1. That should be all we need. Let's save it. Let's take a look at it. Yep, there it is. Notice we got the same sloping problem as we had before, so it looks like we're going to have to add a backward weight on that slope. So let's go ahead and add a backward weight on that slope real quick. That'll be the second slope, so let's add a backward weight. And that other one was 10. Let's make this one 10 too and see what happens. Ah, yeah, that looks good. That looks good. So there's our 45-degree angle. Now we need to add another 45-degree angle that will get us to the positive z, which will give us the 180-degree curve. So let's add that one in. All right, and there's my curve 180-2 that I'm now going to say, okay, I'm going to still keep my current x radius. My x radius is positive. My z radius now turns positive, and because it turns positive, once everything gets out, the forward position of the track will now be a positive z. Okay, so now we need to add the backwards and forwards weight. The forward weight is going to be on the entry point. The entry point is up here. So let's add the forward weight to the curve 180-1. And the backward weight is going to be on the exit point, which will be down here. So let's add the backward weight on the curve number 2. That's cool. All righty. I'm going to still keep it at one center here, but let's add it to down at the bottom here, curve 180-2. And that should give us our curve. And it gives us a fantastic looking curve. So we're doing pretty good here. Look at this. There's our start. There's our 45-degree angle. There's our second slope. Here's our 180-degree angle. Now we got a slope that goes down this way before it gets to the finish line. So let's now add that one in. And here is the next one. Just like with the curve 45, I'm adding a landing here too. And this will become apparent here just in very shortly. So let's go ahead and add that at the bottom here. Curve 180 landing. And I'm now going to put this at curve 180 landing as my center. So I have a camera pointed to the right spot. Save it. Take a look. There it is. No whoopie-doop big deal. I just added an extra 10 loop there. So let's add that last final slope there. And there's the final slope. Same thing as before. No big deal. So let's add the final slope down here. And of course, we know it's sloping because we're keeping it straight because x is not changing, z is changing to a 40, and my y is going down by 10. So we had the final slope. Let's save it. And there, let me zoom out a little bit. There is that final slope. Notice guess what? We've got that little thingy there again. So let's go ahead and let's, just like we did with the landing on the other landing, let's add the forward weight to the curve 180 landing. Forward weight. Let's make it 10. What do we make the other one? Make it 20 or something like that? I think we made it 10. Actually, we made it 15. I'm going to make it, since the slope is not quite as steep on this curve, on this landing here, I'll keep it at 10. So we've changed the curve landing to 10. We've got the final slope in there. Let's take it out. Yeah, that looks a lot better. All right, so the last thing I want to do here is we're going to need some sort of landing that will represent or a finish line that will represent the landing strip. So let's go ahead and add the finish line in there. And there's our finish line. Real simple, real easy. I'm giving it just a 20 width so the cars have enough time to be able to get past the finish line. We're still at a positive Z. Let's go down here, add finish line to the bottom. Save it. And notice that we got in fact, what I meant to do, now I should have done this before, is on the final slope, let's get our camera pointed to the final slope. There we go. Okay, so you can see that we still got the little angle there. So how are we going to fix that angle? Well, we're going to change the background slope, or the backward weight, excuse me, of this particular slope. So we'll now go back to final slope, and let's put a backward weight of 10. 10 seems to always work really nice. That's why I always try it. That's why I always start with 10. Ah, yeah, that's pretty. Okay, that's a nice, pretty slope there. And so this represents the finish line. And that means basically we are done. We got our start position way at the very top there. We go down a big old slope. We do a 45-degree angle. Come back down another slope. We do a curve. Do a 180-degree curve. Come back down another slope and end up at a finish line. Alrighty, so that basically is our entire track. So it really was just a very simple matter of figuring out where the center point is, what position we're going to be at, and then some adjustments on these backward or forward weights to be able to get the sloping to look pretty and to come out nicely. And then it was just a simple matter of telling the system here, hey, this is the order I want you to print them in. And we're pretty much done. Now, why did we have those landings? I told you, I'll tell you at the very end there. Is there something really funky you can do on some of these curves? Once you've set up a curve, there is something called a track bank. I'm going to set for a 23-degree angle here. A track bank basically is a way to be able to set banking on the curve. So I've set the 45-degree curve to a track bank of 23. And what I'm going to do here is I'm going to come down to our track here, and we'll put, man, I can't spell. We'll put our camera back up to curve 45. Let's save it, and let me show you what that banking looks like. There you go. You can kind of see it there. So as it comes down, let me get it. So as it comes down there we go. So as it comes down and it hits the curve here, it's going to do that banking. So you can see the banking right there. So the curve 45 now is banked. And so now that I add the landing in here, the landing gives me a chance to get everything all straightened out before it goes back into the slope. So that's the reason I added the landing inside there. So I could have so when the curve is banked, That way the landing automatically gets everything all nice and pretty. If I found that if I didn't have that in there, if I went immediately to the slope, no amount of the backward weights or the forward weights will get it to look nice. So the landing is very important there for me to be able to get this track back straight. And of course, we can do the same thing with the 180-degree curve down there. All we have to do is to do, and let's do a really good one. Let's do a track bank of 45 degrees on both of those. And see what happens. Track bank 45. Let's see if I can get down there. Maybe curve 180. We'll put it at the end of 181. That'll be right in the middle of the curve. There we go. Okay. There we go. You can see that banking now. Wicked, huh? And of course, again, I need the landing there to be able to straighten back out the track. But there's a 45-degree bank within the curve. So if these cars are going really fast at this point, this will help straighten them out. So that's basically it for our track. Let's get the whole track inside here. I got to figure out better ways to move this mouse here. But anyway, there's our whole track. There's our start. There's our ending. So our next video is going to cover the actual starting gate and the finish gate down at the very bottom. And then after that, we will put everything together and start racing cars. If you like this video, please click on the like button below, subscribe to this channel, or leave a comment. I'd love to hear from you. We're trying to reach 1 million subscribers by February of 2042, so your subscription will help us out immensely. And again, thank you so very much for watching. This is the Virtuoid, aka Mike Smith. We'll see you later.